Okay, this is another example. We need to calculate V out of T. V out here is a voltage. VO is a voltage across this 5 Henry inductor. So how can we do that? Actually, we need to calculate, for example, the Zn, and then calculate the current here. Then we divide the current, and then calculate the voltage. So it is as if you all have a regular circuit. I mean, DC circuit. So what I'm suggesting here that we convert everything to impedance first. So this one here is 20 and amplitude or phase negative 50. So this number one, 20 and negative 50. This is the phase for the source. 20 is just 60 is just 60. Z1 is 60. There's no difference here. Z2 is 1 over j omega c. Omega is 4. So it will be 1 over j omega c, and this is c is 10 milli, which is 0.01. Then Z2 will be negative j 25. And then Z3 is j omega L, so it will be j omega time L, which is 5, and omega is 4, then it will be j20. Okay, so now if you want to calculate the voltage here, the best way to do that is that you can merge these two together, these two in parallel. So you can merge them together like this. Okay, and once you do that, you will have a circuit like this. You have a circuit like this. This is the impedance here. So you will have something like this. So let's call this Z23. Is it Z23? I don't know if I mentioned that, I said that or not. But this is Z1 and this is Z23. This is Z1 and this is Z23. The voltage which is required is here. This is the voltage. Okay. So if I get the current I, and multiplied by Z23, this will give me the voltage. So first I need to calculate Z23 by paralleling Z2 and Z3, and then after that calculate the current. The current equal the voltage, which is 20 and negative 15 degree, and divided by the total impedance, which is Z1 plus Z23. These two in series now. This is the current. You multiply this times Z23. This will give you the voltage, the required voltage, which is VO. Okay, so here this is what I did here. This is Z2 parallel with Z3 equal 500 over negative J 50. You multiply them and divide them by the summation. See here when you multiply 25 times 20 is 500. Negative J times positive J is 1, by the way. J times J is negative 1. And then you have a negative outside, then it will be positive 1. J times J is negative 1. Times this negative will be 1. So when you multiply, it will give you 500. When you add in the bottom, in the denominator, will be J20 minus J25 will be negative J5. Now find this. 500 over 5 is 100, and negative J, you can move it up by positive J. So it will be J100. So this is J100. This Z23 equal J100. Okay. Then if you want to find the total impedance, Zn equals Z1 plus Z2 parallel with Z3 will be 60. This 60 here plus J100. That's it. So you can convert this to amplitude and phase in the regular way. 60 square plus 100 square under square root. Okay, and then you find the phase. 10 minus 1, 100 over 60 will be 59. Then you calculate the current. As I said, you calculate the current Vs divided by Zn. Then how do you calculate the current? It is 20, see 20, and angle negative 15. Okay, and then divide this over this one, Vs over the impedance. 20 divided by 116.62 is 0.1715, and negative 15 minus 59 will be negative 74. So this will be what? Will be In. This is In. So if I want to calculate VO, multiply IN times Z1 or 23, which is, this one is what? Z23 is J100, which is 100, and amplitude J, what is J? J is 90 degrees. So the amplitude is 100, the phase is 90 degrees. So when you multiply this IN times 190 degree phase, this will give you VO. So let us see here, if you want to calculate this one here. Of course, 100 times 0.1715, this is 17.15. This is very easy. And the angle here, IN is negative 74, and it is negative. You add it to 90 degree, equal 16 degree. So this is the angle of the output voltage, so voltage across the inductor. Then now if you want to convert this back to time domain, it will be amplitude. Here's the amplitude, cosine, because we used cosine for the beginning. 4t will not change, 4t plus 16 degree, which is here. That's it. So this is the voltage across the inductor, and it is the same voltage, by the way. It is the same voltage across the capacitor. So if I change this one, I said, okay, and I need the voltage across the capacitor. I need VC. It is the same. There's no difference because they are parallel to each other. So it doesn't matter if I said VO or VC. They both the same. So let's solve this example also and see how we do it here. We need to find VO. What's VO? VO is the voltage across the capacitor. And here, if you want to find the voltage across the capacitor, usually to find it, you need to use Ohm's law. So you need to find the current and multiply it by the impedance, this impedance. So if we want to convert this circuit to impedances like this, then we need to find the total current and multiply by this Z3. That's it. Multiplied by Z3 will give you the voltage. So first we need to find Z1. What is Z1? Z1 is J omega L. J omega L. What is omega? Omega is 10. Omega is 10. Okay. So it will be J omega 10 times 0.5, which is 5. J5. So this is J5. Z2 is just resistor, so it's 10. And then you parallelize these two with each other, parallel to each other. Z1 and Z2, you multiply, divided by the summation. So 10 times J5 is J50, divided by 10 plus J5, here it is. Okay, then you need to convert then to amplitude and phases. Then J50, of course, is 50 and angle 90 degree. And this one you can convert it by using a calculator. Then you can say, okay, 10 square plus 5 square equal, and 2 to the power of 0.5 equal 11.18. So this is the amplitude. What is the phase? The phase is 5 divided by 10 equal, and then inverse 10 is 26.56 degree. Okay, so this is the denominator here. Okay, so now if you want to calculate this, you divide the amplitude. 50 divided by this, 50 divided by 11.18 equal 4.47. And the phases, you subtract the phases. The phase in the numerator is J, which is 90. So it's 90 minus 26.565. This will give you 63.4. What is this? Is for supposed to be 435 again? Is it right? Okay, let me check again. 90 minus 26.565. Then it is 63.435. So actually, I forgot to add a 4 here, a 3 point. I forgot to add a 3 here. 3. So here it is. Okay. Then you need to convert this back to amplitude and phase. Why? Because you need to add it to this 3. To add, you have to convert it back to amplitude, to real and imaginary. So it is 4.47 cosine give you 2, and 4.47 sine 63 will give you 4. So we can prove that. We can say, okay, 4.47 times 63.435 cosine equal 1.999, which is 2, and 4.47 times 63.435 sine, where's sine? Here's it, equal 3.998, which is 4. So it is very close. Okay, so 2.2 plus J4. So now Z1 and Z2 will give you 2 plus J4. You just need to add this to Z3. Okay, so Z3 is what is a capacitor, so it is 1 over J omega C. You can calculate B negative J2. Okay, so now you add this negative J2 to this. If you want to add this one to this one, it's very easy. The real is 2. The imaginary, you have negative J2, and positive J4 will be positive J2. So it will be 2 plus J2. There it is, this one. So this is the total impedance. This one here is very easy to convert. 2 and 2 will be 2 square root of 2, which is 2.824. Or you can say 2 square plus 2 square under square root. You can do that. The angle is 45 degree because it is 2 and 2. So the angle is 45 degree. So this is the N, amplitude and phase, and real and imaginary. Then now you can calculate the input impedance. It is Vs. Vs is 50 and angle 30. 50 and angle 30 degree. You divide it by this one here. So let us calculate it. So the amplitude is 50 divided by the this one 2.828 equal 17.678. So this is the amplitude of the current, and the phase is what? 30 degree. Vs is 30 minus what? Zn, which is 45. So it will be negative 50. So this is the current. This is the current. So if we need the current, this is the current. So now what we need to do is to find VO. This is the last thing. What is VO? Is the current. This current is moving like this. The current is moving. Is splitting here is okay. The capacitor. So the current, total current, which is this one here, multiplied by this Z3, which is negative J2, this will give you the voltage across the capacitor. So IN is this IN multiplied by Z3. Let us do that. Multiply the phase, the amplitudes. So it is 17.678. You multiply by the amplitude here is 2. So this will be 35.36. Why it is 355? I don't know. Maybe. Okay. Anyway, it's very close. 35.355. It's okay. And you add the phases because you multiply. The phase here is negative 90 degree because it is negative J. So it will be negative 90. Okay. Plus you add the phase here, which is negative 15. Negative. So it is negative 105. Okay. So this is the phase for VO. If you want to convert it back to a time domain, it will be very easy. The amplitude is the same, 35 cosine 10t. Here's 10t, and you take the copy the phase here, negative 105. Negative 105. Okay.